Hey everybody, how you doing today? I'm going to be showing you examples based off the concepts we talked about in class today or yesterday, depending on who you are. So this is more inverses examples. And I first, this is actually take 2 of this lesson, and take 1, the examples ended up being too hard. I was struggling with them. So I thought, let's simplify this down a little bit. So example 1, I have f of x equals x squared minus 4 with x less than or equal to 0. If you think about this graph, y equals x squared minus 4, that is a y equals x squared graph that has a vertical shift of down 4 and would normally look like a U. But that would fail the horizontal line test and would not actually have an inverse. So for this, we're only going to graph the negative side of it. And to make our and just to think about things a little bit easier, let's consider this coordinate right here. When is y equal to 0? Well, that's going to be when x is equal to 2. So this coordinate right here is 2, 0. So let's find the inverse. So I have y equals x squared minus 4, which becomes x equals y squared minus 4. That was me performing the inverse. I add 4 to both sides, so I get x plus 4 equals y squared. I square root both sides. I get positive negative root x plus 4. Okay, now this graph. If you think about this graph, a square root of x graph, but it's been moved to the left 4. So at negative 4, I have positive root x plus 4, which goes like this. But I also have negative root x plus 4, which goes like this. This is not a function. And on top of that, this is an entire, like a full-on parabola, whereas this is just half a parabola. So how do we know which one is right? Well, my answer for that would be to look at some coordinates. Going back up to here, I've made a tactical mistake. This coordinate was not 2, 0, it was negative 2, 0. Thus it would fit in the domain. Now, if I find the inverse of this point, that's 0, negative 2, and that is on the bottom half of the graph. So this is the right and proper inverse, which was the negative variety. So y equals negative square root x plus 4. Okay. So yeah, you just need that key point to let you know about the positive or negative. You could always graph it to make sure. I had the point, this point was negative 4, 0, and then negative 2, 0, and the graph ends up looking like this. And I'm not on team graph paper, so it's going to be tricky to see, but this is a reflection over that line y equals x. Okay, in order to work with the rest of this, I need to do a quick example number 2. Let's just find the inverse, and let's not have it not be a tricky one. In fact, I'm going to pull this straight off your homework. I'm going to look at, I'm looking at, oh no, that's new stuff. Where is, here we go. So I'm looking at number 3 from your homework from last night, when f of x was equal to negative 1/3 x minus 5/3. And then when we did the inverse of that one, we ended up getting f inverse of, no, wait. We don't do that yet. I'm sorry. And number 2, this is what we want to say. Given f of x, find f inverse of, pick some number. Give me a number, Elliot. Negative 8. Let's find f inverse of number 8. Now, there's kind of 2 different options here on how to solve these. Option 1 and option 2. In option 1, I would only use option 1 if you already have the inverse of f of x. So f inverse of x. And we did, because this was a homework problem. This was last night's number 3. So when f of x was equal to negative 1/3 x minus 5/3, our f inverse of x, our f inverse of x ended up being negative 3x minus 5. And then once you've found the inverse, you can just plug in the number. So if I have f inverse of x, I'm going to plug in -8. So f inverse of -8 is equal to -3 times -8 minus 5. That becomes 24 minus 5, which is 19. So f inverse of -8 is 19. That works. Now, option 2, that's the technique I would use if you never once had the inverse of this. If you never found the inverse, remember how inverses x becomes y and y becomes x? Well, when you're doing f inverse, they're giving you an x value, but it's the x value of the inverse, which means it's the y value of the original. So we're going to take the original function and basically change the f of x to -8. So it becomes -8 equals -1/3 x minus 5/3. And now just algebraically solve this equation for x. I can multiply both sides by -3. That gives me 24 equals x plus 5. And I subtract 5 from both sides and I get x equals 19. Wow, that was so fast and I never even had to find the inverse. So that's option 2. Once again, you take the value, which is the x value of the inverse, which means it's the y value of the original function. So I plugged it in for y of the original function, or in this case in for f of x. Solved it algebraically for x, and I got the answer straight away. One more example. Let's have it be this, that prove that f of x equals -1/3 x minus 5/3 and f inverse of x equals -3x minus 5. Prove that these two functions are inverses. And as I talked about a little bit in class, we're going to do f of f inverse of x, and we're going to do f inverse of f of x. And we're curious if they are equal. And not only that, we're really curious if both of them are equal to x, because if both of them are equal to x, we've proven it. And if it's not, something's wrong. So f. I'm going to use the f equation. I'm going to plug in the inverse. So it's going to become f of -3x minus 5. So I'm going to go through my f equation, and everywhere I see an x, I'm going to plug in this stuff. So I have -1/3. Here comes the x. So -3x minus 5 minus 5/3. This becomes x plus 5/3 minus 5/3, which, what do you know? You get an x. Other one, f inverse of f of x. So it's going to be f inverse of the f equation, so -1/3 x minus 5/3. So I'm going to go through the inverse equation, -3. Here comes the x stuff. So instead of x, I'm going to plug in this. So -1/3 x minus 5/3 minus 5. -3 times -1/3 x becomes positive x plus 5 minus 5. 5 minus 5 is 0, and I'm left with x. So were they equal? Yeah, they were. And they are inverse. That proves that, yes, they are inverses. Well, that is the end of the examples of this lesson. So at this point, go ahead and get going with the practice or the homework. And I think starting tomorrow, we're not going to look at, now we're going to use this inverses on exponential functions and find out what happens. Thank you very much. I'll talk to you later. Bye-bye.